back to telling you about who won what amazing prizes. At ETHIndia, we want Web3 to win. And that means we want to get all the smartest people in the world in this one roof and really have them experiment with everything that's kind of out there to break things, kind of push the boundaries. And this is exactly what we did this weekend. ETHIndia was an incredible success. This is our 4th time running it, and this is the biggest one we've ever done as ETHGlobal. We have 2,000 attendees, 15 of them are hackers from 217 cities, and 30% of them are new to Web3. Not only are they here from 35 different countries, but we have representation from every single state in India, and that is amazing. So these 15 hackers spent the last 36 hours building the most incredible set of projects, and the goal here is for us to talk about all the things that they built. I'm super proud to announce that 478 incredible projects came out of this hackathon. This is the most we've ever seen, and that was a big, long, and incredibly energetic morning for all of us. We went through all of these projects, and we're going to show you what some of those top projects are. But for the next 3 minutes, I'm going to have you clap a lot because there's a lot of people who are going to thank for making all of this possible. So first of all, congratulate yourself for submitting almost 500 projects. And I also want to thank all of our judges who talked to all these hackers. So thank you for Prabal, Praneeth, Augie, Jack, Ayush, Mohak, Anubhav, Shomik. Come on, got to thank them. Mayur, Fran, Rohit, Kartik, Kush, Raghu, Jason, Pritham, Mustafa, Sumit, Muskan, Pareen, Harsh, Nandit, Angela, Janil, Puneet, Tomas, Garvit, Ishank, Ryan, Abe, Ankit, and Dan. And our 28 incredible partners are going to be giving away $250,000 in prizes. So please join me in thanking OneEdge, Arbitrum, Filecoin, Polygon, Scroll, Airstack Alliance, Base, Celo, Chainlink, Ethereum Foundation, Mantle, Powerloom, Push, Safe, The Graph, Waku, XTC, Octo, Huddle, Lighthouse, MetaMask, Mona, OKX, XMTP, Zeta Chain, Creso, and Fidelity. All they're going to be talking about all the prizes you've won from them, and all that will be announced shortly after the demos. So let's go back to all the projects. 478 projects were submitted at 9 a.m., and we spent the next 6 hours going through all of them thoroughly. I'm super proud to announce that out of this whole submission and judging process, we have 13 incredible finalists here. So without further ado, well, actually, before we announce them, now, these are our 13 finalists. It's also a long day for me. Let's congratulate our 13 finalists: 3Transform, Bet on Balls, Pixel Police, Graphite, Phoenix 5, ZKP2M, Blockchain, Hivm, Safe 2-Lane, Cabri Chain, Masala Wallet, Multilane, and Cryptic, Cloak. All these 13 teams are going to come on and demo what they built, and we're going to do that shortly. But before I go, I want to make I'm going to thank an incredible amount to all of these teams who submitted a project. A lot of you are here. This were so many teams that we got that we're going to actually have to do 2 slides this time. So all 465 teams. I want to thank you for submitting a project, making something that you're proud of, presenting it to our amazing set of judges, and pushing yourself to do something incredible this weekend. Just because you were not one of the finalists does not mean you were not good enough. Our goal with the finalists is to show some incredible projects our judges are excited about. And I want to thank all of you for making something and shipping something incredible. Give yourselves a massive round of applause. So before we jump into these 13 teams, and by the way, you can see all the projects here now live. If you head over to ethindia2023.devfolio.co/projects, you can see everything that's public that came out of this event. And we're going to talk about all the prizes very soon. But before you go on and we do the first demo, we want to make sure that we can make this event better for you and everybody else that comes in after. So you'll be sent a link here from our side, and if you can just fill out this quick survey, it's just 10 questions. You got to just rate things 1 to 10. It helps us make things better for the next thousands of people that come in. Just take 2 minutes, tell us what you liked, what you did not like, what else can we fix. All that stuff makes our lives easier and makes it more amazing for the next set of people who come in. And we're going to be giving away 10 hoodies. Just going to be raffling these away, and we'll ship it to you wherever you are in the world. So please do that. We'll send a link later. But enough talking from me. Let's get to our 13 demos. So without further ado, let's welcome our first finalist of this weekend, 3Transform.
Getting started with Web3 can seem kind of daunting. Presenting before you 3 Transform. Let's start by signing in. Most Web2 users do not have a wallet per se. So we can sign them in with Google and build a wallet for them. So once I sign in with Google, I have a wallet address for that particular account. When I click on Let's Start, this is the app that we have built. A Web2 to Web3 transition tool, wherein you enter any URL that has a Web2 app. So in this case, let me consider reddit.com. And I click on Start the Magic. So what this is doing is it is generating ideas of how I can effectively and productively integrate some aspects of Web3 in my Web2 app. This can have many use cases. Two use cases that we are focusing on. Number one being education. 30% of builders here are new to Web3 and might not be that familiar with how it works. Secondly, enterprise users. Enterprise users have to keep up with the times, right? So maybe your boss comes up to you and says, like, we need to keep up with the times, integrate Web3 in my app. So now, based on the URL, I have generated some ideas. So here I can see decentralized voting system, tokenization of karma points according to Reddit. So let me consider, I can choose any one, and I have this editor for me. So the approach is here. I can provide it additional context, like I need upvote and downvote maybe. Down vote. And I can click on generate code, and it will generate a Solidity smart contract for me. Now, this is powered by large language models, and I do not recommend my user to directly use the code generated by LLMs. So I have an open in Remix IDE button that will port the code into the Remix IDE, and we have provided detailed instructions on how they can test it over here. Once I do that, then I can click on the download hard hat button, and what will this do is on the user's behalf, it will create a hard hat project. It will do the hard work of compiling it, zipping the files, and upload it to Lighthouse storage. Once this is done, this will be downloaded as zip file. And here, as you can see, I don't think you can see, it might be too small. But yeah, the contract is here, the artifacts are here, the build information is here. After that is done, we do not end here. We have given them a one-click deploy button as well. So you click on Magic Deploy, and this contract will be deployed for the user. It might take some time, but yeah. So with the magical features, first of all, idea generation, then we come to magical code generation, then we magically download hard hat, and now comes Magic Deploy. It will give me a contract address, and I will be the owner of this contract. Alright, you might think, okay, he ends here. No. Now, based on the contract, we give the user exact information of how they can actually integrate this smart contract into their front-end applications. So here you download the artifacts, you copy the front-end, and you download the dependencies, and here each of the function written by smart contract is mentioned here, and you can see that the parameters are also verified. Alright, so this is the app. If you are interested in the technical details of how this is all working, I have included this diagram. You can find it on my DevFolio submission as well as my GitHub repository. And you can also check out the submission by clicking here. We have a live demo up and running. If you need access due to a rate limiter, do feel free to reach out to us. Thank you to Pargat, Vinay, and Arya for being amazing teammates, and our friends there who helped us out, Nilanj, Jay and Buran. Thank you so much for your attention. This is Team Somehow.
Hey everyone, I'm Ovia. I'm a researcher at Octo by CoinDCX.
Hi everyone, I'm Nidhi Singh. I work as senior engineer at Walmart. And we are team Bet on Balls. Bet on Balls is an on-chain prediction marketplace focused on sports betting. And for the POC today, we've focused our entire product on cricket because we are in India and who doesn't love cricket, right? Let's straight away head to the demo now. So here we have built a simple prediction marketplace where we have pulled the API data from a cricket API. And I've already put in a small bet on an Ireland versus Zimbabwe match. And I'm going to put in another bet by just shifting my wallet real quick. Let's do this. So now you can see that I'm connected to my wallet. I already have a few bets before, not a gambler, just FYI. I'm going to predict to bet a bet on the Ireland team. So currently we have deployed on a bunch of Hivm chains. You can see that the demo is on Polygon. However, this is multi-chain. There's an interoperability factor still missing. But what we have done is, you can see that the bet has come here that I've bet for Ireland to win. I'm also going to place another bet, for the other team. So here we have Ireland versus Zimbabwe. So let's give Zimbabwe some love as well. Let's bet a bit for them.
Because otherwise, it will get done around.
So once you predict something, it basically comes on your existing predictions. And we have used Chainlink APIs, Chainlink functions specifically, to be able to fetch the response data when the match gets over. And once the response data is fetched, you can see that if you are won, then you will be able to withdraw your share of funds. And if you have lost, then your funds have gone into the pool, which is distributed amongst the winners. So Ovia here is helping me with the Oracle settlement. So the idea was to not build something too complex, but build something fun, using which we can onboard users, using which we can show that, hey, crypto is not just all about DeFi or just about heavy infrastructure stuff, but it's also about building cool stuff, about having great experiences, and about having experiences which you can, have a sort of trustless environment. Okay, this broke. Well, this is how demos are supposed to go, I suppose. So you can see that my past predictions are still there, and the bet that I place, which is Ireland, yay, Ireland won, and I am able to withdraw my funds right now. I'll just make a transaction here, and this should be good. And we have a cool thing as well that we added, which is a bit of social media fun. If you have bet on something to predict on certain teams, you can also share it on socials, and you can get your friends to retweet. I'm going to do that right now. And if you're here watching this demo, please like the tweet, retweet, and let us know how you like this product. Yeah, that's about it. We have a bunch of future... a lot of credits to Sri Lakshmi, who prepared the whole business model and future scope, and I would love for her to take this time to talk about what this is. So this is the tech that we use. We've made it a multi-chain marketplace, and we finished the demo, and this is our team, which is incomplete. But yeah, for the future scope, one of the main things that we think that our marketplace could actually make money from is subscription model and parlays. So parlays is something that's really cool, where it's a win big or lose big situation, where you place multiple bets under the same category, and if you lose one of the bets, you lose all. Which all comes to the marketplace again. But if you win big, right? And we want to also have another unique feature where we want to give points, XP points, to folks who actually make accurate bets. And through this, you're also building an on-chain profile on betting, and you become an influencer in the space, right? So you're not just betting on the games, but you also start like playing game on the ecosystem itself. Right, and this is also mobile compatible. So it's obviously you're not gonna sit in the laptop every time you're gonna start playing. You can just go anywhere, anytime, and create a bet and make some money. And that's from us. And thanks a lot. Yeah, thanks everyone. I stay cleaner.
Amazing. All right, we are back in flow. Next up, our third demo, Pixel Police. Please give them a big round of applause.
Yeah, sounds good. Okay. On. Good.
Hey everyone, introducing Pixel Police, a protocol that enables organization to verify a digital content, be it image or video. That is like verify that's not generated by an AI or it's an deepfake. In case of citizen journalism, when citizen sends image to news.org, they cannot verify the authenticity of content. It can be an image or video sent by photographers or local that it's authentic, right? This becomes even a bigger problem because of Gen AI, when anyone can spread generated image, and this can lead to misinformation. And this one, a lot of people are familiar with the bombing of the explosion of Pentagon, right? That resulted into S&P 500 drop by 30 points. This can become even more problematic when it's about the war crimes.
So now let me introduce the architecture of Pixel Police. So we basically built a roll-up using Stacker SDK, which basically can work with any L1 and L2. So in our roll-up, we design a custom state machine and custom state transition function, which facilitates addition and basically any kind of operation on any digital media content. So just wanted to kind of like give you a little overview over the node architecture. So basically it contains three different clients: CKVM, rollup client, and the RPC server. All the state transition functions, all the editing operations which are happening on the digital content happens inside ZKVM, so that we get the proof that the operation which is happening on the digital content is actually correct. And with rollup client, we proceed with the state transition function, and we leverage RPC server like for different calls. So let me just give you a demonstration of like how does it actually look like in operation. So we built this application built on this particular rollup, and now I will be testing one of my friend's image. So I just open the camera right now, and let me take a good picture of my friend. Yeah, so I took a picture of my friend, and now what I am doing is I am basically, yeah. So as you can see, like when I actually took the picture, the state transition has been performed over the image data, and the image has been attested. So basically when I actually captured the image, the device secret key basically signed that particular image, and that particular attestation has been verified inside ZKVM, so that we can get the proof that this particular image has came from actual device. And now let's perform a simple operation on this particular image. Let's just grayscale it. When I click on grayscale, now this particular image will get grayscale, although I'm deaf, so you won't be able to see this, so sorry for that. So again, like the grayscale operation, again further as a state transition function, and the proof corresponding to it gets completed on the ZKVM proof. So now let's suppose this particular application can be used as a citizen journalism application, where a citizen wants to basically share this image with certain news platform. So let me just share it, and I just created this sample CNN news platform, and and now I can see this particular edited image on this news platform.
Yeah, so now let's say we are on some news platform like CNN, right? And we have all the images here. Now we have a button here saying view history. So once I click this image, it'll redirect this to our Explorer platform, which is gonna show you all the different versions of the image along with, you know, the version ID and the operation which was performed on the image, as well as displaying the image there. Basically with this, you are not just proving the authenticity of the image, but you are also proving the origin of it.
Yeah, so what we basically did with this application was we had a mobile application which captured image where you could verify the authenticity as well as the origination of the image in any social media application or journalism application through our Pixel Explorer. So, but then the question is, who will adopt this? So there is a standard called C2PA which is being developed in collaboration with Adobe, Microsoft, and a few big names. And their aim is that publishers, creators, consumers have the ability to trace the origin of different types of media. And that is what we have built. This is a standard which is work in progress, and this implementation, Pixel Police, is one of the first implementations of this standard, and that too on blockchain. So imagine Adobe and Microsoft adopting blockchain. There could be other use cases in the realms of social media platforms, legal and forensic analysis, and advertising, in addition to news. That's it from our end. Thank you for your time, guys.
All right, that was demo number 3, Pixel Police. Now we're going to get set up with number 4, Graphite. Please give them a big round of applause.
People all committed the with
Hello and namaste, Bangalore. It's fantastic to be here. I want to begin by thanking you all for making us so welcome halfway around the world. Our project is called Graphite because it's a lightweight solution to a hard problem using snarks. We're here representing Oxford Blockchain Society and HomeDAO, as well as EdgeDAO too. The first question is, why graphs? Graphs are very present in the real world. In Web 0 here, we are all nodes on the graph. By that, I mean we have nodes and edges. That could also be in the case of blockchain, where we have wallets connected by their relations to one another, transactions and the smart contracts you choose to interact with. The problem with graphs is that computation is very expensive. You can have very rich properties, for example, the number of clusters, PageRank, like Google uses, to rank web pages when you search them. However, this comes at a cost that often scales in the number of nodes squared. We want to find a way that allows this to be done cheaply and efficiently so we can prove rich properties about graphs.
Now, the obvious solution to this kind of problem is to take a snark. A snark is O1 in complexity and gets around this problem that you have exponential or ON squared algorithms, especially when you're scaling to graphs that are tens of thousands or even millions of nodes wide. The problem here with the naive solution is that the circuit becomes extremely large and there is a tedious developer experience. If I today want to snark a graph computation like a shortest path algorithm or a spanning tree algorithm, then I need to go learn a DSL, a domain-specific language like Cairo, Circom, or one of the many others out there that exist in these isolated crypto communities. And as someone who might be a Web 2 engineer or a beginning engineer, as a machine learning engineer or a data scientist, it is a very high barrier to entry. We decided to break down this barrier to entry. We've built Python bindings that sit on top of Noir and make it super easy for any developer to use snarks. The way this works is that we allow access for any developer to be able to make use of this, this technology. And here you can see a graph of gas costs when you're doing a sort of graph computation on-chain in Solidity compared to if you're using Graphite. And as you can see, Graphite is 0.1, whereas Solidity is sort of quadratic. And after 4 nodes, our solution gets better than just doing it simply in a smart contract. But the real sort of insight is when you start looking bigger, because obviously real world problems require a massive number of nodes. And you'll see that even after 60 nodes, we get to the point where the algorithm can't even fit in the block space because of how much gas is required. And this, I think, clearly visualizes our value proposition. 30 lines of code to 3 lines of code. We go from something that is a complex DSL to a simple Python library. And this has been published on PyPy. Anyone can install it using pip, and any engineer can use this in their Jupyter notebooks or in their Python files as they normally would use any library.
Thank you, Manoj. I would like to give you some examples of our in action. So, first of all, airdrops. The protocol running an airdrop is incentivized to reward the people that contribute the most to their protocol. How can they do this? Well, they can page rank wallets, which is users, which is people like the people here, and hence see who are the key contributors, who made the key connections, who give the key volume, which can be calculated through the page rank off-chain and then proved and uploaded on-chain to be verified very cheaply by the protocol themselves, hence rewarding correctly the people that are giving back to protocols in airdrops. We see a graph of this here on some example wallets, and the wallet with the highest page rank here will be rewarded proportionally to this. Another example is if you want to off-ramp. It's very important to check that a wallet hasn't been engaged in something like wash trading. Currently, this onus is purely on the off-ramping service. This allows us to give the user the proof that they have not been wash trading or similar malicious behavior. They can simply upload that proof on chain and it can be verified cheaply and quickly by the off-ramp service. This not only adds security, but it also makes it cheaper and safer. I'll now pass you over.
So one of the applications that we've built that I'm super excited about is trustless on-chain DEX aggregators. So I'm not sure if a lot of you know this, but existing DEX aggregators like 1inch actually have a trust assumption built in that the path that they generate is the best path. But you have no guarantee of this. So what we've built actually enables you to get a guarantee on-chain that if you're doing a swap from one asset to another, using our graph algorithms is actually the best possible path, the best execution. And this enables use cases like DAOs that want to manage their treasuries fully on-chain.
All right, and now we can get started onto the demo. So here is the demo of an example Jupyter notebook that shows you how you can use, how easy it is to generate a proof. But yeah. So I can just click run all, and it installs PyGraphite, which is the Python library that we published. We have some help functions that allows you to visualize the graphs. So here is the graph that we are running operations on. It shows where the nodes are wallet addresses, and the edges show value transfers between those wallet addresses between a certain period of time. And we want to be able to see if a particular wallet, i.e. a node, has been involved in wash trading. So a existence of a cycle where there is positive value all around the cycle. And then you can you can literally execute the ZK proof just by running this single line, which connects to the Noir backend, which you can see to the right. But you can rewrite this Noir backend in any particular language. It doesn't have to be Noir, and then generates the proof that you can verify on a smart contract. Where we are going to the future is, well, graphs are highly expressive algorithms, and there is a lot of standard algorithms that you can compose, and the composition of all of the graph algorithms allows you to explore many of the computational spaces that were previously very difficult to do due to develop a UX. And we would like to invite you to be part of our journey in unlocking that computational expressibility. This is our page for Graphite Lib, and thank you so much to HomeDAO and ETHGlobal for hosting this.
Thank you, everyone. If you want to live in a physical community,
time's up. I'm going to interrupt you guys.
Teachers at the end.
Nope.
Thank you.
All right. I told them this earlier. I'm going to interrupt. All right. Next up. All right. I'll get them set up, and then we're going to go into all of this. Are you ready? We're not getting you back into DeFi. So, 10, 9, 8, 7, 6, 5. I'm just counting. I have no idea if you're actually doing anything. Well, it's going to get set up in a second. Please join me in welcoming Phoenix.fi.
So, I tell you, looks it. I don't know what things like this doesn't relate to you. You know, those odds that jump. Well, very good, very good. Here's coming on. I know. Yeah, hello. What? Med Fuck. Including I'm find my street.
Hi everyone, we're Finalists.fi. We're a liquid staking platform on Filecoin. Basically, user can stake their fill and earn rewards, and also we provide loans to the storage provider based on their on-chain reputation. So let's hop into the demo right. Okay, so if you have fill laying around in your wallet, so come and stake in our pool and earn rewards. So this is a very simple, like staking in any AMM or DeFi platforms. Okay, so you can see, and let's get the transaction going. And if you are a storage provider on a Filecoin, you need fill to stake in order to be the participant in the node. So for that, we're providing loan, and this is based on the on-chain reputation that the Filecoin storage provider has. So now if you're a storage provider, you can just onboard as a storage provider.
Oh, I'm the FSC. Okay, so control.
As the transaction is going on, let's go to the next page. Here you can request the amount of loan you need. For example, let's assume 5 fill.
We should have it. Come on.
So as soon as the request is sent, we start the calculation of the on-chain reputation of the source provider. For this, we're using a service called decentralized computing service called Lilypad. So basically, we are running an ML model that will calculate the collateral amount the source provider has to pay based on their on-chain history. Now, as this model is trained on the data from the mainnet, so let's pick a miner from the mainnet and check his reputation. If he needs a loan of 5 fill. So as you can see, the model is running. It will take some time. So in the meanwhile, let's see how actually we are calculating the reputation.
Yeah, he just that one little the time that things but
So for where in here you can go ahead.
So basically we need two things, right? The data of the on-chain miners with their transaction history, and the weights that will give to the data parameters that will calculate the exact reputation score of the miner. So for that we are basically fetching these parameters like adjusted power, sector totals, active, false, recoveries, and win count. And we can see that
Run ML models on Lilypad, and you can see like on the top right corner we have a miner with a good reputation, like he has asked for a loan of 1,000 fill, and he has the reputation we have scored is around 829, so and on basis of that he needs to submit a collateral of 200 to get a loan of 1,000 fill. So this is how we are calculating the reputation. Now moving on to the next step. Okay, so the loan is now we can move to the admin panel. Move to the admin panel. Yeah. So after the loan is requested, you can see you can see it in this dashboard. Yeah. So now you can approve the loan amount from the pool based on the reputation. Okay. The reputation, the address got selected here. It was 819 something. You can just
What you like? We haven't done nowadays.
So we are basically calculating a formula that is 1 minus the reputation score by 1,000 into the loan amount. So here the loan amount is 5, so the collateral will be around 1. So we'll add here. Then
see what's some buttons.
So now apart in the storage provider, you can pay the loan as a Filecoin allows us to change beneficiary addresses basically to share the mining rewards with the pool. So we are allowing the miner to change his beneficiary address so that the mining rewards or a portion of mining rewards will directly be shared to the pool in order to repay the loan. And after that is done, you can just place the after the whole process is approved, you can place the collateral and take the loan. So this was our demonstration. Thank you.
Thank you.
Right, I'm up.
Awesome. All right. Well, now it looks like I need to learn how to stall for at least 15 seconds, if not 30. But good news is we're halfway there. This is finalist number 6. They did something super cool. They're using ZK with real-world payments and on-chain stuff. So I'm going to just say slowly, I don't know how to stall properly. But please join me in welcoming our 6th finalist of the day, ZK P2M.
What does it mean?
We got it.
Yep. Yeah, good afternoon, everyone. Thank you, Kartik, for the shout out. So we built ZK P2M, which stands for ZK Peer to Merchant, and it is a fiat to crypto on ramp. It is trustless, it is instant, and it's powered by ZK proofs. So let us get started. As an on ramper, when I come to the protocol, I enter the amount of USDC I want. I will enter 0.1 because I'm fiat poor, and then I'll create an order. Let's switch it to advanced and confirm. So when I come and create the order, beforehand an off-ramper has already deposited USDC to the protocol, and upon creating an order, the on-ramper is given a time period where they have to perform the off-chain payment, produce a proof of the off-chain payment using ZK, send that proof to the contract for verification, and if the proof verifies, the contract unlocks the USDC to the user. Yeah, so this transaction has been mined, and this gives me a Razorpay pop-up where I have to do the off-chain payment. Here you're paying to a merchant and not some random dude on the internet, which means the merchant has already been KYC'd, and it should prevent any frauds. Also, you can pay using any of your favorite payment services, including credit cards, debit cards, and UPI. For now, I'll just use UPI. So once the payment goes through and we receive a confirmation from Razorpay, the UPI calls the prover in the backend. Yeah, so the prover is up, and this prover initiates a TLS session with Razorpay and also splits the session key with the notary using MPC. The response that is fetched by the server from Razorpay is signed blindly by the notary, and then that signature along with the proof is fed inside a ZK circuit. The ZK circuit redacts all the sensitive data that you have in the response and sends all of that along with the proof of computation to the chain. The contract verifies the proof and then unlocks the assets. Yeah, so this all happened in the background, and the prover has already sent a transaction to the chain, which we should see here. Yep, 45 seconds ago, we received an on-ramp transaction, and I should have received 1 USDC on the chain. Yeah. Also, this is not just payments. You can use it, this is not just for India. You can use it to on-ramp in any country using any fiat currency. And this is not just for payments. You can use this same flow to bring any Web2 data on-chain and perform Web3 execution on top of it. Thank you.
Awesome. All right, I may have some good news for you. I think we figured out the tech issue, so let's find this out live. Please join me in welcoming Blockchain. Yes.
Okay, so GM everyone. So we are a team from Blockstock IITR, and we have created Blockchain, a federated learning network built on proof of stake and micro rollups. So what is federated learning? Well, federated learning is a scheme where there is a network of clients. These clients have some local data, and they train models on that local data. They now send these local model parameters to a central server called the aggregator, and this aggregator collects all of these model parameters and aggregates them and sends them back to the client as the base model for the next epochs. So this is how federated learning over the epochs improves accuracy and train machine learning models. So it is a privacy preserving scheme because the data has never been out of the client's system. So this was developed by Google back in 2016, but it has some of issues. Like the problem with federated learning is that the existence of malicious clients. They can sabotage the network and reduce its accuracy. Along with that, there could be free riders that don't meaningfully contribute to the network, but can still reap the benefits for that. So how do we solve this? Well, proof of stakes to the rescue. We just build this network on top of a proof of stake system where the clients have to stake in order to participate in the network. The clients can earn rewards for training these models and improving accuracy, but if they do any malicious behavior, then we can slash them. This way, we can ensure cryptoeconomic security on top of the network. The slashing conditions basically identify outliers in the network and measure the correlations between the previous epochs and the current epochs using a Crumb algorithm and a correlation algorithm. So this is our basic architecture. So user can just come up to the aggregator and request for a particular model to be trained. The aggregator now sends these models to the network of the clients, which start the federated learning scheme. There is a stake and there is a slashing manager which ensures the proof of stake and no malicious behavior happens. Now, the slashing conditions have to be verifiable, but they cannot happen off-chain due to impractical reason and high computational cost. So that's why we are implementing a roll-up architecture where we can post the updated model parameters and have a chain. a state chain where we can manage all of the model parameters for each epoch for each client, and also do the off-chain computation verifiably, so that if there is a malicious client, we can identify and slash it. So that is why we are including a roll-up architecture, because it creates an immutable trace state of each epoch. We are using Stacker to build it, and now I would love to show you the demo of this project. So yeah, this is our front page. So you can just connect with MetaMask. And the next, connect, and you're inside. So now let's look into the user dashboard. So yeah, so now you can create a new task, and you can just specify what you want. So let's say test FL. And we can identify, like, let's say we want to train a CNN model. We can give other parameters like the activation function, the optimizer, the desired accuracy. And we can also pass in our own model that we want to train it upon. And we can start the session. And now we have to pay a base fee so that there are no spam attacks, so people do just spam the network. Pay now. So yeah. Also, we have deployed our own contracts for slashing and managing rewards, but this is a project that would be perfect to implement on top of EigenLayer as an actively validated service. So whenever that is a developer-friendly process, we would love to build on top of that. And yeah, so the transaction went through, and then we can see, if we refresh this, that our test FL is going on. So we have already a completed transaction setup, and we can click on that. And we are trained it for 3 models, and one of them as malicious. So this is just a UI to kind of show that. And we can now download the trained model as a user. And yeah, this is basically the user dashboard. Now we can go back and also show you the client dashboard. So when you log in as a client, you obviously have to stake a particular amount in order to get in. Okay. Takes a while. Part of Pradana. Since there's some problem to help. Let's wait for it to finish. Aku salah timing ni tak? Kita memang sih tak? Oh yeah. Okay, so now that the transaction gone through, now we have onboarded as a client, and we can see all the ongoing transactions that have happened. We can see the completed transaction, some completed epochs, and here we can see a list of jobs where we can start working off. So yeah, this has been a basic overview of our project Flockchain, and yeah, thanks for having us, and it was lovely to give a presentation on this.
That was awesome. All right, next up, Hivm. Please give them a big round of applause. Hey everyone. So we've built a hybrid Hivm, which is essentially a hybrid intense virtual machine. And yeah, so essentially the problem that we're trying to solve is that intense solutions that exist these days are either super specialized for a single use case like Uniswap X, or maybe one is Fusion, or there's another end of the spectrum where they are very generic like Anoma or Flashbox Suave, right? Integration of these intent-based solutions is difficult. So the first thing that we're trying to address is how to make it simpler. We're also trying to make it simpler for developers to easily integrate transaction flows which require multiple interactions, as well as allow the developer to figure out how to align with either a declarative or imperative paradigm. Yeah, so this is what I was essentially talking about, where a spectrum exists for solutions of intents these days. What we're trying to do is to give the developer the control of where do they want to align, whether to build an imperative solution or a declarative solution, or something which essentially aligns with both. And so what is exactly that we built? We built a domain-specific language, which is essentially a way for developers to express their intents in a way where they still have control over how to express the intent on a high level in terms of the transaction flows, but they're still able to leave in gaps where those generic operations like swap or bridge or consolidation can be serviced by an external solver who is competent in that. The DSL compiles into a bytecode which is executed on our Hivm, which is a stack-based virtual machine. We can probably go to the architecture diagram to. So this is the DSL that we have created. You can see that there are essentially three primitives. There's a consolidated step, which is essentially responsible for making sure that there is a certain amount of funds on the given chain. So it essentially internally figures out how to route the funds such that the enough funds are there on the destination chain as described. There's a swap primitive, which is pretty self-explanation. Then there's a call primitive, which just calls a transaction, right? And this is compiled down into this bytecode through assembler that we wrote. And the consolidate and swap operations are idempotent, which means that they are executed based on demand. This is the high-level architecture that we have. The DApp creates a high-level description in the DSL that we created on how the steps needs, what the intent needs to do on a high level. Wherever they need generality, they just use our primitives. It's compiled to a bytecode. It's stored on a intent micro rollup, which provides durability for the status of intents. Solvers come in, they interact, they provide solutions, and we use 4337 for to make sure that the transaction execution is pretty good. Now we go to a live demo. So the first step is essentially for the DApp to create this DSL and compile it down to a bytecode. So we'll just show you a demo of that. So this is essentially an assembler where this particular DSL is compiled down to this bytecode and it gets stored on the rollup for further processing by the solvers. And now we are essentially going to start our micro rollup and a solver, and then we're going to essentially demo on the front end how the intent solving works, how it interacts with the solver and the rollup. So we start both services. This is a front end where essentially a user is able to buy an NFT, and the high level flow here is that the user's funds are distributed on different chains, and ultimately the user essentially wants to buy NFT on Arbitrum, which costs $5. So the intent will essentially make sure that in the consolidated step, it will make sure that the account on Arbitrum has enough funds. It already has enough funds. It's idempotent, so it does not do anything. Then it makes sure that once enough funds in terms of USD have been bridged, it will swap to make sure that the enough amount of USDs is available to buy the tokens. And once that is done, it will actually execute the actual NFT purchase. The green steps show which part of the bytecode has actually been executed, and you can see that already the intent has been fulfilled and the NFT has been bought. And all of this happens on mainnet, by the way. This is essentially a high-level overview of how everything works. And I think let's go into the last slide where we discuss some benefits of the HVM. So what is the benefit that this provides, right? It allows the DApp developer to figure out how to align with either a declarative or imperative approach. They are able to, using this DSL, they are able to tap into either paradigms based on how much they want it to be generic or how much they want it to be imperative. It is completely deterministic compared to an approach of using an LLM where, there's a prompt and the LLM generates a transaction. In that case, the LLM can make some mistakes or it can hallucinate. This deterministic approach guarantees that this will never happen. And the biggest value out of this is that it simplifies integration with dApps where multiple transaction or complex interactions with multiple DeFi apps is needed. Instead of integrating all of the solvers or APIs manually, you're just able to create a high-level representation of what needs to be done, and it's delegated and solved by the solver network. And for the next steps, we'll be working on solver decentralization and expanding our DSL to make sure that more primitives are supported. Thank you.
Awesome. Who doesn't love limit orders? Intents. All right, give it up for HIVM. Next up is Safe to Link. Let's give a big round of applause.
So, hello everyone. So, I'm Kaushik and
hey, this is Kaushik.
So, we built safe tooling. So, what is safe tooling? So, let's take a problem statement. Let's say you want to transfer a crypto to your friend and you have his wallet address. So, the sum is huge. So, what do? You cross check. So, you might perform a test transaction to verify whether it's the right account. Or let's take another example. Whenever you gift a crypto to someone, so there will be always a escrow contract, or there will be some sort of institution which is involved in between. It might be Binance or Waziryak, something like that. So we built something called as share tooling. So here it is, how it works.
Yeah, thanks, Kaushik. So that was a problem. So basically, we know that the payment, although it has evolved, so there is still a problem that we are not so sure about the destination address, and we double check and all those things. So the solution that we are giving through the help of safe tooling. So instead of push models, which happens usually in the payment sector, right? So you have a wallet and you have an address. So what we are proposing is a pull-based model, where we can actually, a recipient can withdraw the funds without actually going through any escrow. So that's something that is possible with the help of modular smart accounts. So basically a lot of account abstraction wallets, right? They provide this feature of programmability. So that's something that we are proposing as a solution. So one of the things that we did was to how we can actually do the payment with the help of a link, actually, instead of actually just getting to know the recipient. So the solution has a minimal technical stuff. So let's say we're going to create a link, right? So what's important? There has to be a secret. So it could be a voucher or anything. You'll have a seed, and from that we actually generate a public key, and that we store it along with whatever condition. Let's say you want to transfer $50. So those conditions will be putting it on the programmable extension of the wallet. And then the secret will be shared with the other person who can actually regenerate and prove any type of recipient. So since we have the public key, any sort of proofs will be verifying via digital signature. So this is a high level of how we do the safe tooling via link, how we can share without actually going through an escrow. So let's do a quick demo. So this is actually, Safe is one of the account abstraction wallets, which is modular. And we have created a module, which is, for safe tooling. And what we are running is on top of this safe wallet itself. We are running this application. So you can actually select the asset, and then you just have to select the fund. So this, if it's a first time, it will install this module into the safe, and it will batch if there is any configurations as well. So right now we are just setting this configuration. Sorry, we can even relay through whatever the safe account provides in their wallet, but let's just confirm this transaction. So once the transaction goes through, before itself we will get to know the link, but once the transaction goes through, we can just share this link with anybody. So if it has been confirmed, so we'll get to know that 0.01 Ether is there to claim. So this is basically, with the help of seed, we reconstruct this, and we index it in our get the index from the contract, and then we display it. So here is the trick. So we want to make sure that the recipient seamlessly can access this. So basically, recipient should be able to access this gift. They should not be able to know the wallet address. So we are removing the beneficiary aspect, right? So what we can do is that we allow them to create a smart account from anything, literally. So let's say the beneficiary wants to create a social login. From the social login, we actually create a 4337 based smart account, and so we take that beneficiary and prove to the smart account that we own that particular secret, and that will be funded. So we'll do we'll just have a look into the transactions as well. So as you can see, there was no transaction initiated in a push model, so we actually claimed it. So the transaction in a safe original account, how it looks like. So if you go to the transactions here, so you see that 0.01 transaction has been done, which is a withdrawal, which is done by the recipient, not the creator. So we can even cross-check. They didn't even pay gas. They just logged in with the social login, and they got access to the fund. And we can cross-check this, transaction, which is again 437. We can even verify the user ops. But as you can see, the user did not pay for the transaction fee. So our paymaster actually paid for it. So this is how we want to onboard the next crypto wave. with the help of a different approach of pull model, by leveraging the account abstraction, which is, we can make it modular and allowing, any wallet to be feature rich. So we have developed it for safe, but any sort of like an account abstraction wallet can leverage the similar functionality. So that's safe to link, but I think we can develop a lot of, future things with the similar concept in our wallets. Thank you.
Awesome. Just a few more finalists to go, so please give a massive round of applause to Cabri Chain.
Hello, everyone. So I would just like to start with a short story. So all of us on a Friday evening, we were sitting in a club having fun, just a normal evening, and suddenly we see something really fishy happening in front of us, a questionable thing, okay? So being the responsible citizen that I am, I wanted to report that to the police immediately. But then there was a voice in my head that said, no, they'll get your phone number, they'll call you hundreds of times, maybe they even include you in that whatever crime you were reporting. So that was when this idea of Cabri Chain, the seed, was planted in our heads, when we wanted to create an anonymously tipping platform for a user where his or her identity remains unrevealed. So so it was not just me. There are a lot of us who, are really scared to go out and report such things that we see around us. So that was the motivation here. Now we'd like to move to the demo. So this is the main dashboard of our system, where the user has to have a MetaMask wallet, as well as we have used anon-Aadhaar authentication, so that there are two things that we want to achieve here, is that one Aadhaar, one wallet, so that there's no unnecessary spoofing in our system, and also we want Indian tippers to tip about the crimes that they see. So here we connect our MetaMask wallet, and on onboarding on our system, there are 10 tip tokens which are transferred to your account, and based on those tokens, you can stake some of it whenever you are giving a tip. So this is just the normal flow of our website. Yeah. So this is how the user onboards. Once the user clicks on login, and there's your Aadhaar key. So Aadhaar is a unique identification, national identity that the government of India gives you. So using that, we onboard the user on our system, and the user now has 10 tip tokens in his account. Now the user can, so there's another module that we have, which is a CAPTCHA. A cognitive assessment of the user, so that for ensuring that the user is actually tipping in his or her right mind. So this is just a simple GUI-based cognitive assessment where you will be shown 4 images, and after that you'll have to select the order in which they were shown, just a normal CAPTCHA that we have on our websites. Okay, this just takes some time to load. Yeah, so you just now need to remember what the series was. So it was second. Yeah, so you straight away, you gone to the tipping the submit form. Now here, we have a description ready with us. So this was some thing that I saw happening in front of me. I just put in all the details here. And since these we do not want these details to get manipulated maliciously, we have stored all of this using Lighthouse on Filecoin. And once we enter all of these details, so the necessary information that the user can give us of the crime description, the type of the category of the crime, the date when the crime was about to happen, and the nearest police station to the crime, and the number of tokens that the user is going to stake. So basically, the stake helps us understand how much confident the user is, and helps us increase the confidentiality score of the tip. Now, we also have an option of uploading any images or pictures that the user might have clicked at that moment. Then when we click on submit, the transaction starts. And here, I would also like to mention that we have a backend running on a Flask API where we have 2 models, machine learning models, which help us detect the spam text from a crime-related text, so that we are not spoofing our system with unnecessary details and storing unnecessary details that we don't require. And moving on, the transaction takes some time to load. Yeah, then we also have a police dashboard where the police also has a wallet address, and the police also has an account on the system. and the police is able to go and verify that tip. So the location that we have took, according to that, we route those crimes to those particular police stations in that area, and those police stations can onboard again on the system and approve or decline those tips. And based on that, we have an algorithm that runs, which determines the user rating. So for example, if you've rated 10 times, and every time your tip was correct, the police has verified it and approved it, your rating automatically increases. So from the next time when you are tipping, you are getting incentivized because of the tip that you make. Plus, you also have a high rating, and you have higher chances of police knowing that you are the right person. So yeah, and we also have a chart system integrated, for which we have utilized Vaku, where, for example, in that moment of time, you might not remember all the details, and after that, you might want to let the police know of some detail that you missed out. So that can be done using our chat application, where you can chat directly anonymously with the police and let them know about any details, or if you want to know what is the status of your case, you can do that using this chat app. Then finally, we also have a dashboard analytics. So here there's just a map feature where we show the different type of crimes in that area, how that police was able to safeguard their city well, based on how many crimes were actually solved out of the tips that were given. Yeah. So finally, I would just like to say, with this idea of Cabri chain, even if we are able to solve that one crime, or if we are able to, prevent any heinous crime or deeds from happening, it will really make us proud and happy that we were able to contribute to making this world, crime-free. So, and again, thank you to my team members, Joy, Samay, Kushal, and Dishita, and me, of course, because this was a team event and we really enjoyed. Thanks to ETHIndia, all of you guys, all of the volunteers and everybody, because this was a great event and we had a lot of fun, as I can agree all of us had. Sorry, I'm so excited. So yeah, thank you.
And thank you for that awesome demo. It's really good to kind of mix up all these things and actually use CK proofs for some real world examples. All right, 3 more finalists to go. Next up, let's put them on screen immediately. There we go. Masala, right.
Thank you, Kartik. Hello, everyone. Namaskara, Bengaluru. So we've built Masala wallet, and then we are excited to demo that. So without further ado, I'm going to jump straight right in. We Indians, right, we love 2 things: good user experiences and great masala. So yeah, and at the same time, right, we are the good at the take. So having said that, right, let's get to the problem statement right away. I think Web3 ecosystem has well established by now that private key management is a major overhead, not just for the new users who are onboarding the entire space, but also for the degens who've been around for a long time, right? I'm sure everyone has heard about some close friend or someone you're acquainted with having had their wallet compromised, and it's just not, it's kind of an ugly scene, right? We need to go away from that space. At the same time, in Web3, good user experience should not come at the cost of centralization.
So you should not solve right user onboarding with the complexity and right introduction of some complex and centralized systems.
And at the same time, we are building Reputex, the reputation protocol for Web3. So we really understand this, and this kind of hits us home. It's close to our heart as well. Ultimately, the bottom line is Web3 wallets still they're just not hassle-free. Now coming to Masala wallet, what we've built. It's just very simple things, right? A great, clean onboarding flow, having great, clean user interface, minimal designs, and making it all attractive. At the same time, what are we here for? We're here for a Web3 hackathon. And what that means is that anything that we do, we need to leverage the underlying technology that's blockchain. It's a decentralized network. When we're leveraging the security that exists over there, I think that's when we're doing a really good job. Now, how does it work? Authentication is just a ZK snark proofs. We'll do a demo, and I think we'll get to the architecture and the smart contracts in that process. So just going over a brief technical overview, right? I need to keep this short because we have an entire demo here. We have a Masala master contract wherein we are basically mapping a username to a ZK snark friendly hashed proof. A hashed password, right? And then we also have an entire social recovery mechanism built in, wherein you basically set your own guardian rules and you have your guardians kind of assigned over there. So going back to the whole Web3 flow, right? You just have a username and a password. You enter that, your onboarding system, and guess what? You forget your password, you have your guardians to come to the rescue.
Yeah. So in the whole flow, right, what we are doing, we are simplifying complete user onboarding. And if you see, right, the complete generation of the password will be the off-chain, and we are submitting the proof, right, to the on-chain that we know the password. There were 2 constants in the circuit. one, I know the password, and second, right, the verification of the all the user operations. Maybe it could be multi-call, right? It could be intent-based, right? Whole multi-call. So all the things will be right considered as a circuit, and we will generate the proof on top of that, and then they'll be submitted to the master contract.
So ultimately what happens is we have the verification key, which is part of the verifier contract. And then when you execute a transaction, let's say I want to do like a simple swap or something, I'm going to take the user ops of it. I'm going to take the password and essentially generate a proof that says that, hey, I want to do a swap and this is my password and only I know it. And this can be verified on chain itself. So there's absolutely no centralization over here. And once that is verified, the multi-call triggers a smart contract wallet. Simultaneously, we store the proof to prevent any replay attacks.
So if you see, right, overall flow is very simple, but maybe we are thinking why no one has implemented till this point. Because it was not possible, right, and it is possible because of the 4337 and introduction of the paymaster. So once the 4337 right came in the picture, then everyone start right going to simplification like using the passkey. So passkey right is coming with the lots of centralized components, right? It's like including Apple and Google can change the message format overnight if Sony is configuration providing the better configuration for the cameras. So we should be not dependent upon this kind of the system.
Okay, now I'm going to get to the live demo. Hopefully this all works as planned. So I'm going to try creating a new wallet over here. We can also do the login, but that's not going to be part of this particular demo. Let's give it a simple username, Masala wallet. A password that I'm not going to utter on stage, but I think everyone can see it on screen anyway. So, all right. So what's happening right now? Like we just said, we are using Zocrates over here. So we are generating a Zocrates-based SH8512 packed hash, and then that just went through. So that was stored over there on chain. At the same time, a smart contract wallet was deployed. We can see the address over here. I can click on it and open the Explorer, but I'm going to jump to the next step, which is about the whole recovery process. We are going to encourage them to use recovery mechanisms. So here we have Social Connect that we've integrated by Celo. So essentially we go through the phone book, we go through the contacts, find the user, the emails who have already been part of this, kind of have you select them as your guardians and continue the whole process. Just going to breeze through this process too. So that's done as well. So here we've established a guardian mechanism as well. Like I just said, this adds that whole forgot password mechanism from Web2 that everyone is familiar with. Of course, we need to do more to kind of explain how social recovery has to work. Selecting guardians is a key part of it, and selecting guardians is not something that can be directly controlled through tech, but I think the narrative can be built around it. Okay, so we've added some tokens over there by default to help with this particular demo, and now I'm going to jump on to transferring some tokens. We should have a particular address. Okay, no, that's not it. Please bear with me. Okay, that's now not happened. Let me paste the correct address this time around. Okay, let's transfer about 0.5 tokens. Okay, I think there's some white space. That should be fine now. Okay, while that's happening, essentially what's going to happen again this time around is we're taking the same bytecode. We are also taking the password that's been stored in secured storage. The combination of that generates the proof. That proof is submitted to the particular contract, and then the whole process that we just explained goes through. So I think that is pretty much it with our demo. We have also integrated a lot more screens, but we're running out of time. We're going to jump back into our slides. This is the team. We are the people who kind of like went over and beyond to build this particular project. I think Denver, when we kickstarted this particular hackathon, kind of made a really good point about moving mountains that inspired us. So we thought, you know what, we're going to go all out. We didn't have any sleep over the last 36 hours, and we made all the efforts that we could to like bring in not just a working functional project, but also kind of go aboard with the user interface. And we are really happy that we were able to demo this on stage. Finally, I think our conclusion is that let the masala be in your food. Let the masala in your food be a surprise and not your wallet security. Thank you very much.
That was awesome. It was a great demo. All right. Please welcome our second last finalist of the day, Multilane.
Hi, we are Multilane, and we are trying to make assets interoperable without traditional bridging. Let's say you find something cool on another chain, but unfortunately you don't have funds over there. So the current solution is like you need to bridge funds from one chain to another, and this problem over there is like you need to wait for a certain period, and your funds are now fragmented across different chains. Luckily, we have a different solution to solve this problem. So introducing multi-lane over here. So what we are trying to do here, we are telling the users to come and deposit their funds on one single chain. And as soon as they deposit their funds on one chain, that fund is instantly available on all the EVM chains possible. And then they are free to use these funds on any chain. And at the end of the month, we will give a bill to them saying that you did like 10 different transactions on 5 different chains. Here is your bill. Let's go to the demo part so the things will be clearer over there. So this is how a multi-chain dashboard looks like. Let me go to manage funds, and here you can see I have already deposited 15 USDC. This 15 USDC is currently on the base network. And let me go to Aave and let me go to Arbitrum network. And here the wallet address you see over here, it does not have any funds over here. The 15 USDC you see here on the Arbitrum, it's not actually present on Arbitrum. It is actually coming from the base network. So just to verify this, let me take the address and just see it on RBScan. So as you see, the USDC address over here is 0, but still on the Aave you can see the balance over here. So let me supply some liquidity on Aave. Okay, so here I'm doing the approve transaction. So in the background, a smart contract wallet transaction is getting made, and there are 2 transactions taking place over here. One is the borrow transaction, and second is the approve transaction. So these 2 transactions are getting combined, and the transaction goes in one single batch. So the transaction is done, and you do supply USDC. So in this way, number of transactions is not increased for the user, and the whole UI and the whole flow is same. So just let's wait for this transaction, and as soon as it's done, yeah, that's it. It's done. So you have successfully deposited USDC on Arbitrum without actually having the funds on Arbitrum. So let's just go see how it works. So there are 2 main parts over here. So one is the fetching part, and second one is the making transaction part. So in the fetching part, my Chrome extension will intercept some RPC calls. So this RPC calls like get balance. So instead of doing the get balance directly to the blockchain, extension will intercept and send the get balance call to the multi-chain node. And the balance will be fetched from the node itself instead of blockchain. That's how the Aave UI is getting your balance. And second is the making the transaction part. Now instead of a regular EOA transaction, all the transactions are made through a smart contract wallet way, and we are using Arcana for that. And just for the approve transaction alone here, we are prepending borrow transaction also. So with the borrow transaction, you actually get the funds, and in the same transaction, you are doing the approve also. So how is it secure? So first of all, it's a non-custodial solution, and we are taking an optimistic approach. So what I mean by optimistic approach is we are assuming that user will pay the funds at the end of the month, and second is user needs to ask permission while withdrawing. So you might think that what if multi-lane node are malicious? So at this moment, there is a system known as a trustless withdraw, and what will happen over here is when you trigger the trustless withdraw, cross-chain messaging will happen, and proof will come from all the chains and say that, okay, this guy is eligible for withdrawing so-and-so funds, and that's why this withdraw is eligible. That's why you don't require any permission over there, and you can withdraw the funds if you are eligible. So do we have bridges? Short answer is yes, but we are reducing the bridging calls, cross-chain messaging calls a lot. And we are using bridges currently for 2 things. One is the dispute resolution, and second one is the fund rebalancing. So that's it, guys. Thank you. Thanks for listening to me.
All right. Now we are ready for our last finalist demo of the day, and we'll get to the prizes. So one last time, please join me in welcoming Cryptic Cloak.
Hello. Good. So here I am Dhruv.
I'm Archit.
So we have built Cryptic Cloak. It's a stealth micro-rollup with maximum privacy. Recently, Vitalik quoted that stealth addresses could be a significant boost to practical user privacy on Ethereum. This solves a lot of problems. Stealth addresses are a cryptographic concept which allows us to mask the privacy of receiver in a P2P transactions. Here are some problems they solve. First of all, if user doesn't want to reveal their spending patterns, it can be done with stealth addresses. Secondly, if there's a trader and he has some alpha and he doesn't want to make his trade public, he wants to make anonymous trades, that can be done too. And for businesses, if they want to keep their information confidential for competitive reasons, stealth addresses can do that too. So let's look at some use case. Majority of use case for the first one includes DeFi. DeFi platform can leverage stealth addresses to enhance privacy for their users. And obviously, B2B transaction. Supposedly there are 3-level businesses and they want to keep their information confidential, they can do that. So now let's understand in deep on how stealth addresses work in our platform. So if you see here, there are two parties, specifically sender and receiver. Now receiver does not want any assets to be sent to his public address. So he will go ahead and register his address on our platform, which will generate a stealth meta address. After that, when the sender wants to send some funds, they will get the data from registry. They will perform some computation, cryptographic proofs in cryptography to generate the stealth addresses and the ephemeral public key for the user. These are kind of identifiers for the receiver when they want to scan later. Now, simply sender can send assets to this new stealth address, and for any external entity, there is no link. There's no link between the receiver and the stealth address. It's totally private. So now, in the backend, we just send the stealth address and the ephemeral public key to our registry. It's in the Stacker micro environment. The reason we are going for this approach is this. Currently, you have to set up on-chain registry for each and every EVM chain. In this case, it's a single verifiable entry point registry for all the chains. And there is no setup needed for any new chain who wants to involve in stealth operations. Also, so what we do is that after it's sent to the registry, it stores the state to the Vulkan. We add an app logic inside the app environment, and then it sends this to Vulkan to verify, and then finally settle that to the L1, which is in our case Ethereum. Now for receiver, when he wants to see all the stealth addresses being created for him, he will just scan the registry with his private key, perform some computation, and if the computation match, he will get the spending key to the new stealth addresses which was created for him. So let's actually see this in working. I'm on my sender side, and I'm going to send some funds to this new address. Now this is the receiver, and who does not want his privacy to be public. So when we click generate, it generates the stealth address, other parameters which we just mentioned. And when we go next, we can just enter the amount. Currently, we're doing a transaction on Polygon member chain. So when you hit transfer, this should give a transaction to send the funds. And as soon as we do that, I think this will be a link. So now just wait for the transaction. Yeah. So now you can see that funds were transferred to the newly created stealth address. Moving on, we also have to announce the stealth address to our backend registry. So once we announce, our part is done. The transfer is complete. Now let's go to the receiver side. So now the receiver wants to actually clear his funds. For that, he has to go to the scan site, log in first. This will enter a sign, and after that, we have to load all the. So you can see this is a new stealth address which was just created for the user from the sender, and they are all reflected, but there is no public link on the blockchain. Now we can select the address, and if you want to reveal this private key, here's a private key for this new address, which could be used for inside the app, or if you want to export this private key to any other wallet, you can do so. So this is not like your new EOA which you can transact from. And now we will try to withdraw some funds. So we will withdraw 0.001 amount from this to our new wallet here. And once we do that, we'll just hit withdraw. So here you can see the transaction has been processed, and the funds were transferred from our stealth address to the new wallet. And I am connected as a receiver. So only receiver can access these stealth accounts from his account, from on our website. Now, one great feature about our website is this: if for example, our DApp is no more and you don't want to use our DApp, still you will be able to use the whole state again because the state is stored on L1. So if the rollup is, for example, crashed or our DApp does not work, you can simply spin up a new rollup, which will just coordinate in the same way, and in this case too, you will be able to get access to the funds you had in your account. Because it involves all this cryptographic proofs, so there is no dependency on any chain or any other DApp or any sort of extra things. So that's all about our platform. Let's make privacy a real thing. And
thank you so much.
Thank you so much. In the end, we want to say that rollups are finally real. Thank you.
Well, you see, the last demo is me, so let's see how the demo gods are on my computer. Did you enjoy those demos? Okay, it was good to hear that all of you are still alive and awake. I wasn't sure what's going to happen. Okay, looks like we are almost there. That was embarrassing. All right. Please join me in thanking all 13 of our finalists: 3 Transform, Bet on Balls, Pixel Police, Graphite, Phoenix Phi, ZKP Ethereum, Blockchain, Hivm, Safe to Link, Cabri Chain, Masala Wallet, Multi-Lane, and Crypto Flow. All right, now it's in both of our best interests that I talk fast and end this thing. So, without further ado, let's get to all of our amazing partner prizes. This is how we're gonna do this. There's $250,000 prize to be given away, and the more energy you bring to the room by clapping and actually getting excited about you winning money, the faster I talk. This may backfire. All right, you ready? First up is Runnage. The best use of Fusion API goes to First Crypto for $4,000. Algo Combo wins $2,500, and Fusion Leverage Bot is the third place $1,500 winner. Are any of these teams here? Let me hear you guys shout. There we go. The best use of token plugins winner is Dividend Dispatcher for $3,000. Reputational Micro Lamp wins the $2,000 second place prize. And Easy Cred will be taking home $1,000. Congratulations. And the best app to enhance the developer portal APIs, the winner is Openverse for $3,000, Chain Scout for $2,000, and Benjamin for $1,000. Congratulations to Ben. Next up is Arbitrum. The best library of framework on Arbitrum goes to OpenStylus for $4,000, and PassSync is the second place winner for $1,000. The best stylus project also is Stylish Stylus for $4,000, and Stylite Proxy is the runner-up for $1,000. And the most original prize goes to Dance Heroes for $2,000 and Crossdrop for $500. See, I'm going to go back to being slow again. And the best check goes to ZK Sunday for $2,000. ZK Patreon wins $500. And these 11 teams are going to be splitting up the boo prize and taking home $454.55 each. Congratulations. Then we have Filecoin. The most unique project on the Filecoin ecosystem is SlicePay, RIFIL, and Phoenix Phi. You're taking home $3,000 each. And 12 teams are winning the pool prize, so congratulations to Zero Swipe, Review Pulse, DCert, Block Battle, Harvey Co, DCOM, Cross-Chain Smart Contract Risk Analyzer, 3Transfer, File Market Maker, DCAT, DSATS Protocol, and ETHFit for taking home $916.67. Next up, Scroll. These 10 teams are the best winning Scroll projects, and you're going to be taking home $1,000 each. So congratulations to Subgraph Gen with UCS, Multi-Tenant Account, ZK Face Recovery, Vote, Hardy Harbor Fund, TT911, Mask Melon, Pendulum, Decentral Law, and ZKP2M. This is about to backfire, so Are you ready for me to read off the next list? The pool prize winners are these 135 teams. I'm not going to say all of them, don't worry. But all of you are going to be taking home $51.85. There we go. You have to be in this room, so come on, let me see some energy. There we go. On to Polygon. The best use of ZK VM goes to ZK Bridge, Allow Flow, ZK Face Recovery, and ZK Riz. All of you are taking home $12.50 each. The best use of Polygon ID goes to ZenPay, Digital Interaction, Project Anthem, and Subprime. All of you are also taking home $1,250 each. And the best ZK EVM DeFi Challenge winners are Network Finance, Token Crafters, Spin, and Graphite for $1,250 each as well. And Discrenomics is the best use of DApp Launchpad category winner for $1,000. And last but not least, Block Battle, Cryptic, Cloak, Z-Day Features, and Mass Melon are the honorable mentions, all taking on $1,000. Airstack. Chain Scout is the best overall use of Airstack for $3,000, and Airstack Spam Protector, Snap, and On-Chain Raptor are going to be taking home $2,500 each. And On-Chain Friends and Donna are the third place $1,000 recipient. Congratulations. That's more than 5 people on that team. I have to look at that later. All right, next up is Alliance. Most likely to be a startup goes to Blockchain and Graphite. You take home $2,000 and $1,000 each, respectively. Nebula Wallet, Wagerbox, and Rudy Protocol are the honorable mention for Innovation Prize, and you're going to be splitting, well, you're going to take home $666.67 each. I love the math working out here. All right, next up is Base. The best consumer product prize goes to Flex Wallet for $2,500. Cryptic Cloak is the second place $2,000 winner, and Alt is the $1,500 third place recipient. Congratulations. And the best use of account abstraction and Base Paymaster goes to Soiree for $2,500 and PassSync for $1,500. Congratulations to all those teams. On to Cello. The best apps on Cello goes to Split Monies for $3,000, DigiVoter for $2,000, and Alt for $1,000. Congratulations. USSD Blockchain Wallet is the best mobile app on Serif for $2,000, and Masala Wallet is going to be the best AA or Social Connect app category winner for $2,000. Next up, Chainlink. The best use of Chainlink CCIP goes to Samvad and Unify for $1,000 each. Congratulations. The best Chainlink function winner teams are Moderator and Daily GM for $1,000 each. And Daily GM is also the best use case of Chainlink services, so you're taking home $2,000 in total. Congratulations. On to Ethereum Foundation. The best Anon Aadhaar SDK winners are Back It Up, Agora Crypt, and Aadhaar Shield. You're going to be taking home $4,000, $2,500, and $1,500 respectively, so congratulations. And the best use of Anon Aadhaar mobile goes to Verified Chainx for $1,000 and Crypto Aid for the best social good category winner. Congratulations. Next up, Mantle. The best NFT category winners is Fanatics for $2,500. Crypto Wave is also the second $2,500 best UX winner, and the best infrastructure prize goes to Graphite for $2,500 as well. Congratulations to all of these teams. And the best 2 DeFi winning prizes are Network Finance and Fluidity, and you're taking home $1,250 each. Powerloom. Data Dynamo category winners are Graphite for $2,000, and Masala Wallet wins $1,000 for second place. Data Maestro winners are SnapSwap for $2,000 and Powerboard for $1,000. And the Powerloom contributors are Fanatics, OpenSign, Snapshots, and Beacon Chain Indexer. You're going to be splitting $1,000 equally, so congratulations. Then we are Push Protocol. There we go. Auditron is the most creative use of Push Protocol for $2,500. Certify is the best conditional gating push chat winner for $2,500. And EV Notify is going to be the best channel category winner for $1,500. So congratulations to all 3 of those teams. And Krypton Wallet is the best overall use of Push for $1,500. And the Namaste prize goes to Workroll for $2,000. There we go. That's awesome. Next up, Safe. The best use of Safe Core goes to Ad Astria and Intense times Levered for $2,000 each. Congratulations. The best Safe Core Protocol category winners are Consensus Lead Module and Mishap Manager for $2,000 each. And Nebula Wallet is the best Safe 4337 module category winner. So congratulations to all of those teams. On to the Graph. The best new subgraph goes to DGen Trade for $2,000 and Token Crafters for $1,000. And the best use of existing subgraph goes to Reputation Micro Rollup for $1,700 and Global Web3 Ecosystem for $800. And TBAI is the best use of substreams for $800. I feel like people are taking photos, so I'm going to be in the middle. Next up, Waku. The best overall use of Waku goes to Block IoT for $4,000. Are you in the room? That sucks for both of us. The best privacy-focused project on Waku is Whisper Core for $1,500, and the best game or marketplace is the Battle of Cards team for $1,500. The most innovative use goes to Cypher Site for $1,500, and Justice Protocol is the best network state goods using Waku for $1,500. So congratulations to all of those teams. And then we have XDC. Best use of Fathom goes to Zephyr Shields for $4,500. ZK Bridge is the second place $3,500 winner, and FreedFi is the third place $2,000 recipient. Congratulations. On to Octo. The best app using Octo goes to TradeZK for $3,000, and the integration prize winners are DFIR and 3Transform. You're going to be taking home $1,000 each. Then we have Huddle. Blinker is the best mobile track winner for $2,000. Subtalk is going to be the AI track winner for $1,500, and Arcave is the Metaverse track recipient for $1,500 as well. Congratulations to all three of those teams for integrating Huddle. Then we have Lighthouse. Harvey Co. and Cypher Site are the best overall use of Lighthouse SDK, and you're going to be taking home $1,500 each. I see that team over there. Congratulations. Next up is MetaMask. Gas Genie is the best gas API winner for $2,000. SlicePay and Blockchain are going to be taking home $1,000 each, and Autotron and Nix are the two $500 winners for third place. Congratulations to all those teams. The energy is dying down. This can't be good. Next up, Mona. The best product for Meetup goes to MetaMeet for $2,000, and Horror Place in Metaverse is the $1,000 winner for the best Mona integration. Congratulations to both of these teams. On to OKX. The most novel dApp on X1 goes to DRent for $3,000 and Trace Chain for $1,500. The best account abstraction use case winner is Masala Wallet for $500. XMTP. The best use of XMTP goes to Chain Scout, On-Chain Friends, and Dollar.gg. You're going to be taking home $1,666.67 each. Zeta Chain. We're getting to the end. This is great. ZetaLend is the best Omnichain contract winner for $2,000. The best contract for Bitcoin goes to Omnichain Ordinal Inscriber for $2,000 as well. And the best cross-chain messaging application is Bleed Protocol for $1,000. That was all the prizes. All the projects are up there now on ETHIndia 2023.default.co/projects. The prizes will start showing up very soon. You can also see them on the ETHGlobal showcase. And before we move on to the one other surprise that's coming, I want to give a quick note on some of the logistics. Everything I said here on the prizes is tentative and not final, which means over the next 2 to 3 weeks, we're going to be going through everybody's code. We're going to be making sure that nobody cheated, everybody followed the rules. We're going to be looking at who committed 100,000 lines in one commit. All that stuff is going to happen asynchronously, so things may change. Somebody could be disqualified, somebody could have been missed. If something changes, we have to update everything else to make sure everything is consistent. So please be patient, and we're going to email you confirming that you actually have won that prize at the end of this time. And that timeline is December 31st. So do not email us before that, especially not tomorrow, because we're going to do this in the next 2.5 to 3 weeks. So some prizes may change. We'll be verifying everything, and then you'll be sent an email confirming this is the amount, these are the team members, and this is actually the prize you've won. All right. Those were all the prizes. There's a couple more things that we want to say, but before I do that and let you actually enjoy the rest of this evening, I want to bring on Denver from Devfolio to share a few thoughts. Please welcome Denver.
All right. I think, as you know, my name is Denver and from Devfolio, and I would really like to thank all of you from the bottom of my heart for making it possible for Devfolio and ETHGlobal to be able to bring together ETHIndia 2023 for you. And you might think that you have won something. You won 250K, $1,000 in prizes. We have won much more. The Ethereum ecosystem has won itself 478 projects, each of which I have no doubt will go on to be the building blocks of the future we build together, right? And that's makes all the sleepless nights, all the effort, everything all over the years worth it. And again, thanks a lot for that. And today I'll just like to take some time, not much of it, to just demo some stuff that we have been working on at DevFolio, with some surprises as well thrown in. And okay, I think too much alpha there. Is this 5? Okay, all right, let me do this, and I think this should work. All right, cool. First up, we have quadratic voting. Now, we at DevFolio believe in the power of the masses and want to take your opinion to also learn what projects matter to you and how would you like to give back to them. For that, we have built quadratic voting into DevFolio, and if you have submitted a project over the weekend, we have a $20,000 reward pool for you. And you can be part of this experiment. Let me just show you exactly how. Right. All you need to go is to go to DevFolio, go to the quadratic voting tab, and you just get started. You watch a quick walkthrough. You will be able to vote for all the projects that are built over the weekend. You can vote for any amount, like you get 100 votes, so you can divide your votes 10 into 10 and 20 into 5, or any distribution that you like, as long as it adds up to 100. And your vote gets put on the chain using Ethereum attestation service. And then we put it on chain, we do the calculations, and then you can claim it from your DevFolio itself. Right. And one of the reasons why we are so interested in making this possible is that we really believe that giving back to you will make it a better ecosystem for all of us. And so make sure you make your voice heard. You just need to go to this link to start voting. There's certain rules that you need to follow. These are the steps you can follow. I already just showed that to you. But the rules are, the gas fees are on us. You don't need to do anything while voting. Only hackers who have submitted a project can participate in the QV. The hackers who participate, only hackers who vote in the QV process can claim their QV vote matching amount. And the voting deadline is midnight of the 13th of December, right? And we hope you'll all vote, and we'll be able to see the results on that real soon. Another thing I'd like to talk about is how do you keep your projects alive after the hackathon, right? Now, after the hackathon, this is like an oft repeated thing, like, most projects just die, right? But what can we do to keep those projects alive post the hackathon, which is exactly why we have built something called Cheer. So all you need to do is you need to visit any project on DevFolio that has connected all their wallets. If the team members have connected their wallets, you can just go that and you can cheer for the project. You just need to go here, choose a sticker of your liking, thank people as much as you want, tell them they've done a good job, or let them know that you're rooting for them, or just tell them to keep shipping, or of course never stop building. And once you do that, again, this goes on chain using EAS, and who knows, you might just get scouted by somebody, a peer you really like, and that might just be the encouragement you need. But encouragement also on chain. That's what makes it different from anything else, and that's why we think it's really cool. All right, what else? We will also be having some really cool SBTs for you. post the hackathon in like a couple of weeks, you will be, you'll get a really cool SBT of everybody who submits a project at a DevFolio hackathon will get a participant NFT, and there's also another SBT if you are a winner, right? So we'll be rolling this out soon. Lastly, I'd also just take a moment to talk about something cool that we have also built, and that is an all-new DevFolio profile. Now, your all-new DevFolio profile is going to be your one place where you can showcase all your proof of work, be it your proof of work from GitHub, or it be from your proof of work of the hackathons that you have been to, or it be your on-chain thread. So you can check out all, you can showcase all your commits on GitHub, you can showcase all the links, all your blogs that you've written, all your proof of work in one place. You can also showcase all the projects you've built on DevFolio, and also showcase all your on-chain threads that you've been given, right? So that is something we are really excited about, and you can enroll into this by going in and joining the beta on DevFolio, and very soon we'll roll it out for everybody else. And last thing, all of you know by now, it's no secret that DevFolio loves Ethereum, and if you're hosting an Ethereum hackathon in the city, we can help. Just holler at us at hello@devfolio.co, and we'll help you set up your hackathon in your city and give you access to the exact same tools that we use to put together ETHIndia and hackathons such as this. Yeah, thanks a lot, folks.
Thanks, Trevor. All right. I need all of your attention for 3 minutes, and then we're going to go back to enjoying the rest of our evening. All right. This is the most important part of this hackathon. We're going to use up all of our leftover energy and thank everybody that made this whole thing possible. Are you ready? Let me try this one more time. Are you ready? All right. First of all, I want to thank all of our amazing people here that made this possible, starting with all of you as hackers, all 17, 15 of you who spent the weekend with us making something that you wanted to build. That was awesome, and we really appreciate you doing this. Next up, all of our incredible judges. Please give them a massive round of applause for talking to all hundreds of projects today and giving them feedback. All of our mentors and volunteers who were there the entire time, making sure you get the technical help, you get any of the logistics figured out, and all the behind-the-scenes 24/7 coverage that they had to do. All of our amazing speakers who did all these workshops, telling you about how to use different protocols, and all of these incredible set of partners that work behind the scenes to put the best event possible and do all of those things that help you move the rest of this ecosystem forward. And special shout out to everybody that, because they won't thank themselves, Aniket, Anish, Anshuman, Arpit, Aryans, Swarnim, Pratik, Preet, Pritika, Ayush, Calvin, Vanchika, Shriya, and Denver from the DevFolio team for being an incredible host for ETHIndia 2023. And last but not least, the rest of the ETHGlobal team who have done so much work behind the scenes. So please thank Vikram, George, Wilbur, Maggie, Nuno, Fred, Polly, Rory, Ruchi, Minnie, and Moaz, Emily, Andrew, and Jacob. All right. That was 60 seconds. I got 120 to go. So the finalists, 13 teams came on. They demoed what they built live. And then we went to prizes for all the other partners that were giving away prizes for their categories. But I want to tell you about what these finalists mean. For us, our goal is to have people build something they're excited about and what they're passionate about, which means we don't treat these events as competition, and we really don't want people to be first, second, third, and compete for something and really take that away from actually doing something because they think that should exist versus maximizing for some reward. And as part of that, we keep the whole process separate from the main judging of all the prizes. So for being a finalist, effectively all 13 of those teams came in first. And in addition to any other prize they may have won, ETHGlobal will be giving them 500 USDC. In addition to all of that, wait, there's a lot more. Not only are they going to get 500 USDC from us, every member is going to get 10 Zipolia each, so you can test as much as you want. An ENS domain also will be given out to every team member. Anyone who wants to come to any Pragma event for next year gets a free entry. If you want to buy a hardware wallet, you get $100 off a Grid Plus. If you are not already on Lens, you get a Lens protocol handle as well. And a $500 USD reimbursement to any of our events next year in person, which means you can come join us in London, Sydney, Brussels, Singapore, San Francisco, or at DEF CON. And this is what you get for being a finalist. 60 more seconds to go. Last but not least, we can't end an ETHGlobal event without telling you what's next. So I'm super excited to announce all of our 2024 events, starting with in-person hackathons. We're going to have London in March, Sydney in May, Brussels in July, Singapore in September, San Francisco in October, and DEF CON in undisclosed location in November. Not only that, we want to make sure everybody can be part of all these events, even if you can't be near those cities. So we also have a lot of async hackathons, and the first one is going to be in January called LF Go, all about the Go stablecoin. We're going to go back to doing a lot more about ZKs with Circuit Breaker. This is everything ZK. Scaling Ethereum is going to return in April. That's a month-long event on how do we actually make scalability and practical applications with crypto. And our biggest flagship event of the year is ETH Online. Will take place in late August to early September. All of this is public on ETHGlobal.com. That officially concludes all of my talking for today. Thank you, everybody for joining. Let's go outside and enjoy the party. Thanks to 1inch. Thanks for coming to ETHIndia.